So this is our presentation. We have been working with fertilizers derived from leftover materials from marine industry, like catching of fish and algae. Interest algae, brown algae in Norway for the time being, and we catch a very, very big amount of fish. So it's really access to such materials for possibly making fertilizers in Norway, which could be an alternative for conventional animal manure. Ishita has made a review that marine fertilizers are actually quite common many other places in the world. And we saw earlier today that kelp extract was used in Norway, at least in northern. It's not so very to use these materials. So we have, now you can take next slide. We have had field experiments over 2 years, last year and this year. And the first year it was less advanced design with 5 fertilizer treatments compared. And this year, 2020, we expanded a little bit. But both years we have been using residues from seaweeds, that's called algae fiber. And we have been using fish bones, which have been conserved with formic acid, and that we abbreviate FB for fish bones. And then we have a control, of course, with no fertilizer, that is abbreviated Key 0. And then we have had a green control treatment, a positive control, which is with a commercially available fertilizer in organic farming in Norway, is based on dried poultry manure. We call that GO, which means green organic. And then we have a mix, that is a mixture of the algae and the fish bones, because the fish bones contain a lot of nitrogen, phosphorus, and calcium, whereas the algae contain a lot of potassium and sulfur. So the mixture could actually be quite good. So that were the 5 basic fertilizer. You can of course read more details here, but in 2019 we compared this in oats, cereal type oats, which was grown as a sort of cover crop. And under we established perennial ley, so that we could also harvest the same field this year, the first year ley. So I'll show you 2 yield results of the 2019 trial. Then in 2020, we established a new trial on the same experimental field, but on the other side of the field. And there we grow ryegrass, and then we had the same treatments, but this time we had 2 rates of nitrogen. So we had low level and very high level. So you can see the first year we tried to apply 2009, 106 kilo of nitrogen with each type of fertilizer. And then in 2020 we had much higher rates, because we wanted only to apply fertilizer in the spring and then have 4 cuts or 5 cuts even of the ryegrass. We only were able to take 4. And then we aimed for 300 or 600 kilo of nitrogen. And that's quite high, but we did the same levels in a pot experiment, so we wanted to keep it equal. So, and there you see, in addition to the algae fiber and the fish bones conserved with formic acid, we also had some fish, and that's rated F, not FB. Okay, so then you can take the next slide. That was about the experiments. So I think I will show you some pictures on the next slide, how it was looking in the spring when we established the field. It takes a little bit time before it comes to the screen. I hope it comes now. Maybe you already see it. Have you changed the slide, Nikolaos?
Yeah, okay.
Oh, it just takes a little bit of time then. Yeah, here it is. Okay, so you see we had nice weather. And if we start in the middle, you see how we incorporate the fertilizers in an experimental plot. So you see our colleague Marius has on the left side of this experimental plot where he is working, he has already incorporated the black material, which you can see there. That is algae fiber, and it's probably a mix plot because there is also some white material on top of the black material. So then it's a mixture of algae fiber and fish bones. In the bucket side, you see fish bones, and on the left side, the black bucket, you can see the fresh fish bones, which were just ground by, so it almost looked like porridge. Okay, so then you take the next slide. Here you see how we had to treat the algae fiber on the left side to make a small, what do you call it? Almost like pellets that we could spread evenly in the field. And you also see the green organic manure, this dry poultry manure in the small glass there on the right side and in the big bags that the farmers can buy. And I already mentioned this nutrient content that the algae are rich in potassium, fish bones rich in nitrogen, so it's a good thing to mix them. But you should know that an issue with the algae is that they contain a lot of sodium and they also contain a lot of arsenic. So actually it may be a big challenge to get rid of algae fiber in cultivated soil at all if we get some new regulations where arsenic is included in regulations for heavy metals. Okay, next slide. Yeah, so for the results, last year we first harvested the oats. We had a lot of weeds in the field, but we had the results were quite reliable anyway. So we harvested the oats in the end of July. And as you can see, we have a very big difference between the treatments. So without any fertilizer, we had about 2.7 tons of dry matter per hectare, and then a slight negative effect of the algae fiber. And some positive effect of this poultry manure, not too high, and that's maybe a reason why we bought this new equipment for incorporating manure into the soil this year, because last year we just used a rake, and that was probably not good enough because I think this was discriminating the poultry manure a bit, that we didn't incorporate the manure deep enough. So, but you see a very big positive effect over the fish bones and the fish bones mixed with algae fiber. So that was the yield last year, positive effect of fish bones. And then what was very interesting that this year we just kept the field there, and we had 2 cuts of this first year perennial ley, grass clover ley. And what we could see that it grew very well in the plots where we applied algae fiber last year, and that was quite interesting. So you see the control again on the left side there. And then the green manure, sorry, not green manure, green organic or the poultry manure, GO, that also have positive effect. The fish bones, which were applied last year, seem to, they are a little bit better than the control, but the effect is not very large. So it seems that most of it was used up last year, but the algae fiber have a very good residual effect also when it was mixed with the fish bones. And if you take the next picture, you can see that was especially visible in the seems to be that the red clover really thrived with this algae fiber. So on the right side, you can see a plot with the algae fiber and fish bones applied last year. And on the left side, it is this poultry manure. So you see the much more clover and much more vigorous growth of the clover. So we think that maybe the red clover really like to have a lot of potassium. Okay, so for this year's, the next slide, please. Then, because now we're running out of time, but just to make it very briefly, with the ryegrass experiment, when you summarize all the 4 cuts, you get the highest yields about 8 tons of dry matter per hectare. And that is about the double as you get in the control. If you look at the left column there, K0, that is the control. And you see the same result with the algae fiber. You have not any positive yield effect, but with the different fish bones and the poultry manure and the mix, you get higher yields, just to put it very basic, easy, yeah, to summarize it, but you see some statistical valid differences there. And and now what we're going to do, if you take next slide, then of course we can split this and look at the patterns between first cut, second cut, and so on, so that you can see how the dynamics were in the field over time. But I think it seems to be a bit slow now. Yeah. There you see the ryegrass field. You see on the mix that it was really the color of the grass was quite blue. So you see a lot of nitrogen being applied here. And on the left, right side, the algae fiber, much more light color. Next slide, please. You can just go now to the final slide with some conclusions. Here you can see the dynamics. We don't have time for that now, but the conclusions, yeah. So I already mentioned some of this, that of course you need to incorporate the manure in the soil, and to apply 600 kilo of nitrogen, it's far too high in the field experiment with ryegrass. That's I think we never do that again. The growth effect of the acid conserved fish bones is very rapid, that we have confirmed several times. The fresh fish bones, they also have positive effect, but it is less rapid. And what we could observe with some bags buried in the soil, you see on the right side, they're very popular feed for soil animals. So rapidly in bags. So maybe that's why also the growth effect is a bit not so rapid. And then it could be quite exciting to see if we get the same positive effect next year of the algae fiber, but this ryegrass will not survive. So, okay, that was my presentation.